Okay, so this is section 1.1, which is about rectangular coordinates, and the material in this section is helpful for the assignment because you do have, I think it's just one question on the assignment that talks about that's relevant to this section, but it's good to go over it, and I like to, in this class, do a lot more application problems when I can, just because that way you can really see how this stuff is used, and that's why we have our application assignments. So just as a review, we have the Cartesian plane, which is what we use to graph things in 2D. And it's also called the rectangular coordinate system because you're sort of forming rectangles as you plot points. So if we look at the image on the left, you've got it divided into 4 sections, which we call quadrants. And we start at the upper right, and then we go left, down, and then to the right. So we move counterclockwise. This is consistent with what we do when we get into trigonometry, which will be week 6. So when we talk about trigonometry, we also do everything counterclockwise. The horizontal line is called the x-axis, and the vertical line is the y-axis. And then that center point we call the origin. So that's just a review of terminology there. The picture on the right shows what we have is called an ordered pair right here. And that's how we write points. It's basically a set of coordinates. We have a number for how far it is on the x and then how far it is on the y. And we have it in alphabetical order. It's a specific order, which is called y. It's called an ordered pair. And so it has this terminology, directed distance. So sometimes you might hear the x called the directrix. It's not a very common term, but occasionally that pops up in a science class, less so in math classes. I've seen it more in things that are science related with this other term called a directrix. So if you hear that, that's coming from this directed distance kind of idea. And I think the textbook goes a little bit more into that. You can look it up if you want more information. You don't really need to know that word. It's not very common. So this is the Cartesian plane. It's named after René Descartes. And so first example is making a scatter plot. So a scatter plot is just where you're plotting ordered pairs. It's a scatter plot when it's not connected. So scatter plot does not connect the points. And we're not going to do this by hand because there's no reason that you need to really do these by hand other than if you're doing it for your own notes. I wanted to show you guys how you can do this in Desmos. And that way, you know, because you're going to be doing a lot more technology stuff in other classes. And so using Desmos to do the graphing for you is going to be really nice. So I'm going to sort of try to have it open at the same time. So this is one of the most common graphing calculators, DESMOS. So it's called Desmos. I actually have met the guy who invented this website and came up with it. His name is Eli. He's a very nice guy, very smart. So that was really cool. I was really excited. So I've shared these with like recommended calculators because Desmos has like a graphing calculator, a matrix calculator, which we'll use for week 3, and a scientific calculator. But their main thing is the graphing calculator. So when you just go to the website, you can just automatically click graphing calculator, and then here it is. So if you want to plot a table, you have 2 options. You can enter in each ordered pair by hand. And so we've got this table of month and temperature. Now you have to decide what is going to be your input or your x, and then what is going to be the output or the y value. Whenever we have time is always going to be the input value. So time is always x because the input, the x value, is usually called the independent variable, and we don't really control time. So you may notice here, if I go back to my slides, So I said the table shows the lowest temperature on record, and I specifically didn't leave the variables in there because I wanted to talk about how you know one is X and how you know is Y. So this is X. Oops, no, that's Y. I just said that time is going to be the X. So we've got the table shows the lowest temperature on record. So temperature is the output. It depends on the input. So the Y always depends on what the X is. So that's Y in degrees Fahrenheit in Duluth, Minnesota for each month, where X, and we're going to use X equals 1 to represent January. And so that comes from our table here, because you can see it just says 1. And we're all familiar with X equals 1 representing January. So I left those out because I wanted to kind of talk about how you know what is X and what is Y. And if anything is listed as time, that's going to be X. And it's not necessarily on the order that it's given to you in the sentence. If you notice in this sentence, it gave us the temperature first, but temperature is actually Y, not X. So you want to pay attention and think about, well, what do I have control over, and or what depends on the other variable is a better way to think of it. And that will tell you what is X and what is Y. So our month is going to be, our time is going to be X, our temperature is Y, and it matches what we've got in the table, where it's basically the first column is X and the second column is Y. So when we're graphing this, we could literally just write a series of ordered pairs, and you just type exactly what you would see for an ordered pair. So you've got your parentheses, and Desmos is really nice. It kind of closes it for you. And the first one would be 1, comma, -39. And then you can close it. So if you notice, we don't see it on the graph. So I can use my scroll wheel to zoom in and out, or you can use the plus or minus buttons here. But if you zoom it out enough, there you can see we've got 1 and -39. So if you're making a scatter plot, you can go and write an ordered pair for every single one of these points, and then they'll be plotted. If you hit this right here, that will turn it off, and then it doesn't graph that. So an alternate way to graph, if you have a series of points, is you hit the plus and then go to table. Then you can basically copy the table in right here. And I don't think it will let me, let's see if, I don't think I can copy and paste directly from my slide. Maybe I can. No, that's not going to let me. So usually what you can do is you can just copy and paste directly from, you know, if it's in the book or something, you can, and it paste it in, it will do that for you. But here it won't. So you'd have to actually enter in the numbers. And if you hit tab, that will move to the next part of the table. So you can make your scatter plot using this table. So you type the right numbers. You can see that it starts forming the dots. So I'm going to just enter all of these in and make sure that I'm actually entering them in correctly. So these temperatures are Duluth, Minnesota, which is practically on the other side. It's like very top of Minnesota near Canada. I've actually been there a few times. It's a really nice place. They have a really nice aquarium for being a sort of relatively smaller town. So it's interesting. Okay, so this is our scatter plot here, and I'm going to open this bigger so you can see it. So the temperature goes up and then it goes back down. Now, this may not be the best view, and when we're graphing, we want to make sure that we have a really good view of what we're looking at. If we're graphing this temperature, the time, we don't have negative months, so we don't need the negative part of the graph. So that would not be part of our domain because we don't really need negative. So you click on the wrench here, you can go to graph settings, and then I could change the x-axis. So I could say, let's start at -1, and then let's go to 13, and I can tell it to count by ones. And so you can see, just by adjusting that, we get a much better view of what our scatter plot looks like. And we get it's a It gives you, it gives you a different picture, but it's a better, easier picture to look at. And so that's a scatter plot. You're just putting in your X and Y values and lining them up. Desmos is really nice. If I hold down the mouse, is it hold or is it right click? I know I've done this before. There, if I hold it down, sometimes it doesn't respond, but you can change the color. So I can change it on purple. You could connect them by lines if you want, but then it's not a scatter plot because scatter plots don't have lines connected. You can change what the dots look like. You can make them X's. There's a lot of nice options here if you want. So this is basically how we make a scatter plot, and this is what I would do is I would just put it into Desmos, and then you have this nice picture here. And if you want, you can go to the settings. You could add labels to your axes. You can change the type of grid if you want. And this button right here, the share button, allows you to give a link, or you can even download an image of it if you want, if you're going to put it somewhere else. So that's Scatterplot. And that's useful. That website's going to be very useful throughout the whole term for graphing. I recommend you bookmark it. But that's basically sketching a scatter plot, and I would definitely use technology for that, because otherwise doing it by hand, it's just, and there's no reason these days to do it by hand. So the next thing in this section is about the Pythagorean theorem and the distance formula. So I have them side by side because you get the distance formula from using the Pythagorean theorem. So the Pythagorean theorem is a geometry equation, basically, where you have a right triangle and you have a squared plus b squared equals c squared. And c squared, or c, is the hypotenuse. And this will come up again when we talk about trigonometry, because right angles come up a lot in trigonometry. So we have our formula here. If I took this formula and I solved for c, I would just have c is the square root of a squared plus b squared. So now let's compare that to the distance formula here. So if you're finding the distance between 2 points, and so that is the solid black, you can create a triangle, a right triangle between those 2 points. And you can see that in the pink. And then you can find the distance of each leg, like A and B. So here they have A. If we compared it to the triangle on the left, A would be our vertical. It really doesn't matter the order there. And then you can say that B is your horizontal. And the distance between, how long that leg is basically the difference in y values, because the x value is the same for A. So that's where we get this y2 minus y1, and that just gives you that distance A. And then you square it, because that's part of the Pythagorean theorem. And then the same thing with B is you're basically the difference in those two, how long that leg is just the difference in x values, because the y doesn't change. So that gives you that right there, and that's your b squared. And so the distance formula is literally using the Pythagorean theorem to solve for that hypotenuse, which gives you the distance between 2 points. So if you're someone that has trouble remembering formulas, if you remember how you get there, that could be helpful. Say, oh, in order to do this, if I can't remember the formula, I can make myself a triangle and use the Pythagorean theorem to figure it out. So a lot of our formulas that we use in algebra come from other formulas. There's several that come from the Pythagorean theorem. We have other formulas that come up from different procedures. It's basically working through what you know in a different context and then seeing, oh, what formula do I get? So that's sort of how we come up with different formulas. So the distance formula is basically the square root, and you have to make sure that everything is inside the square root there. And that's the difference in the x values squared plus the difference in the y values squared. So I've got an example here. An airplane flies from Naples, Italy, in a straight line to Rome, Italy, which is 120 kilometers north and 150 kilometers west of Naples. How far does the plane fly? So we are not really given coordinates here, so you have to sort of create it on yourself, and that's what an application does. So we have two options here. So you could do this straight with the Pythagorean theorem, or you can kind of do this with the distance formula. So I'm going to do it with the distance formula just to kind of show you what that would look like and how you would do that. So I'm just going to kind of sketch a grid and say we have our first point here, which is at the origin. And we can say, okay, we're going to say that this is where Naples is. We're starting in Naples. We'll just say that's the origin. And then we're flying to Rome, which is north and west. So I will just stick Rome right here. And so our plane is flying towards Rome. So we want to find the distance between those 2 points. So you can look at this and say, well, we set Naples at the origin. So that will be 0, 0. And then in order to figure out where Rome is, we went 120 kilometers north and then 150 kilometers west. So that's going to give us a negative value because west on our grid is going to be towards the negatives. So that gives us an ordered pair of negative 150 and 120. And so that gives us our two ordered pairs that we can use to use the distance formula to get our equation. So I recommend always writing down the formula before you start plugging in numbers. And this is good practice. So you guys have your application assignments that you need to turn in, and you need to show all of your steps in those application assignments. Because I'm grading not only on did you get the right answer, but I need to know, did you use the correct process? Do you understand the process to get the right answer? So where application assignments, you want to show all of your steps, and that if you have a formula, you need to write down that formula first before you plug the numbers into it. So that's just good mathematical habits. You want to make sure that your square root covers everything it needs to. So you notice that I had to extend it because I didn't draw it long enough. So you want to make sure that everything is exactly as long as it needs to be. Your symbols are correct. Your variables match. You can't just flip-flop variables on me because then it's mathematically incorrect. So about half of your grade is all about, are you showing your work? Are you using the right symbols and the right notation? Is it organized? All of that kind of thing. So it's really important to get a good practice into showing your work nicely, especially if you have to, I don't think the computer science people need this as much because you're not taking as many math heavy classes after this. But if you're going into engineering, you're going to have a lot of very heavy math classes after this. You'll have calculus, you'll have circuit analysis. There's several classes where you're going to be doing Terrence. Yeah, it's going to be a lot of math. That doesn't mean that you can't do it. Just forewarn you. So showing your work and making sure it's organized will go a long way towards doing well in those courses, because that's like half the battle in math, is being organized and making what you're doing clear. If your professor can't follow your work, they're less likely to give you good points because they're like, I don't know what you're doing. So, you know, to get better grades and for you to understand, you want to be very clear about how you're showing your work here. You guys can do this. I know that you can make it through. You should watch my video that I posted in the discussion today about math for engineering, because it actually talks about, you know, why you have to take these math classes and how that does not mean that you have to be super good at math to get through engineering. So definitely watch that video if you haven't. So anyway, with that tangent, back to our problem. First step that I did was to write down the formula because that's always what you're going to start with. Now we want to plug in the numbers. So it's good practice to kind of label which you're going to use for x1 and which one you're going to use for x2. I'm going to just use the Naples points as our x1 and y1 since that's where we're starting from. And then you can use Rome as x2 and y2. So that way, when you have your next step and you're plugging in those numbers, it's clear what numbers you plugged in. So we don't move from left to right. We always go vertically when we show our work. So make sure you're always going vertically. And so now I'm going to plug in my numbers. So x2 is negative 150, and then minus 0, and then squared, plus, and then I've got 120 minus 0. And then notice again, my square root symbol is not long enough, so I have to make sure that I extend it. Because otherwise what I've written is technically not mathematically correct. So it's good to show every step, so that means I want to simplify these. And sometimes it's easier for me to do the inside first and then write my square root symbol. But you want to be careful that you don't accidentally forget it if you do that. So now I need to actually square these values. So 150, it's a negative 150 squared. And when you put that in your calculator, you need to include the parentheses around the negative 150 because you should get a positive answer out. So that comes to 22,500. And then 120 squared is 144,000. So I'm showing all of my work and I'm working vertically, which makes it very easy for someone else to follow what's going on. So I'm going to add those together. That gives me 36,900. And feel free to double check all of my math because I have been known to type the wrong numbers into my calculator. So if you find while I'm going through here that I've calculated something wrong, or if I've used the wrong numbers, let me know. It's better to correct me immediately rather than for me to find out months later that I messed up somewhere when a student asks about it. Like, what happened here? I'm like, oh, I guess nobody caught that. So if you find mistakes, let me know. Because, you know, even though I've been doing math for years, I can still type things wrong in my calculator or accidentally multiply wrong or add wrong and things like that. So final step here is to take the square root. And because it's a word problem, we will use decimal approximation. We're not going to give an exact value because it's a word problem. And if it doesn't specify rounding, it's kind of up to you. So what I'm going to start with is writing down all of the numbers that I see in my calculator because I often see people rounding incorrectly. So I also want to talk about how you round. So let's say I want to round to 1 decimal place. So I'm just going to put a line after that first decimal place. And that 0, it's not just automatically 0. You have to look at what happens to the number after it. So if the number after that is 5 or higher, you round up. Otherwise, it stays the same. So since we have a 9 following the 0, I need to round it up. So that's 192.1. And then our units, you always want to include units when you're having word problems. So our units are kilometers. So I had to round up because of the 9 after the 0. And you should always answer your question as a sentence. This is good practice for the application assignment. The first assignment doesn't really have a lot of word problems on it, but later assignments do. And so you should always give your final answer as a sentence because you're given basically a sentence as your problem. You're given a word problem here. So we would say the plane flies or flew. I guess it doesn't, I don't know what would be the proper tense here. Flew 192.1 kilometers. So you would then give your final answer as a sentence so that it's very clear that you know what the answer is, and you're double checking that you've actually answered the question asked. So I have to go back to the problem and say, oh, it says, how far does the plane fly? So that needs to be, make sure that that is my answer. And you need to include your units, because units are really important. Units play a big deal in some later weeks where you have to end up doing some unit conversions. And again, for those in engineering, you're going to have to do a lot of unit conversions in your engineering classes. So you want to be very careful about units. Now, those in programming, what you can take away from something like this is that when you're programming, you often have to make sure you've got all of your notation in the right place. You know, you can have a loose semicolon somewhere and it messes something up, or you're missing a semicolon. Or if you're programming like formulas, you want to make sure all your parentheses are in the right place and all of that. So for those of you that are doing computer science and taking this class, there's a lot you can learn about being detail-oriented, because that you really need to make sure that your programs are doing what they mean, and so you have to be very exact about what you type in. So are there any questions on this example? Okay. You guys are learning some good stuff today. So the next thing that's in this section is the midpoint formula, and this relates to your first problem that's on the application assignment because it specifically says to use the midpoint formula. So the midpoint of the line segment joining points x1, y1, and x2 and y2. So it's just, if you were to connect 2 points, it's the halfway point on that line. And so the formula is midpoint equals, and then you're literally just averaging the values. You're averaging your x values, you're averaging your y values. So you add them up, divide by 2. One thing to be very careful here is it's midpoint. You do not want to write m because m is slope. So you cannot abbreviate midpoint as m because that means something very different in math. It's best to literally write midpoint. I have seen some people write MP, and that's okay because I can tell that means midpoint. But don't write M, because then you're saying, oh, I'm finding the slope, and it's not the slope. And then you've got something that's mathematically incorrect. You may know what your intentions were to find the midpoint. You found the midpoint, but what you wrote was not right, and that's where I often see a lot of errors, is when what people write doesn't match what they did. So don't write the letter M to abbreviate midpoint. So this is very similar to that first question on the assignment. The Coca-Cola company had sales of 35,123 million in 2010 and 45,998 million in 2014. Use the midpoint formula to estimate the sales in 2012 and assume that the sales followed a linear pattern. So we're told to assume that the sales followed a linear pattern because that allows us to use the midpoint formula. So if I was to kind of visualize what we've got here, we've got 2010 and then 2014, and we have 2 points here. Now, we have missing data in between. And if, like, you know, I could have these points, 11, 12, 13. Okay, I need only 3 points. But these points could be down here. And if we don't assume it's a line, then our estimate is not going to be very good, because the midpoint formula is assuming that you're connecting these by a line. So if I use the midpoint formula, but the actual pattern was not a line, I'd have a terrible estimate. So that's why we're saying assuming that they follow a linear pattern, because that allows you to use the midpoint to estimate that out. So We're assuming a linear pattern. And then we don't necessarily need to say that when you use the formula to estimate the sales in 2012, because 2012 is the midpoint, is the halfway point between 2010 and 2014. But if they were told us to estimate the sales in 2013, we wouldn't be able to use the midpoint formula because that's not the halfway point. So we're allowed to use the midpoint formula here because they're giving us a year that is halfway between. Now notice that I did put years on the horizontal because time is always on the horizontal. So even though the first numbers they gave us were the y values, you have to think, well, what is actually depending on what? And those values are dependent on the year. So year is the input, those values are the output. So that's how you have to kind of determine what your graph looks like. So we can write ordered pairs, and we've got 2010, and then I can ignore the units for now and just write the number. So I don't have to convert it to like the full number. I can just use the number they give us and just understand that these are measured in millions. And then the second point we have is 2014, and that is 45,998. So if you are not given the ordered pairs in the problem, you should write them down. That's part of taking good notes and showing things mathematically, is to write down what your ordered pairs are. And then that way I can see, okay, did you put them in the correct order? You know, did you have your time first? And I can check that out. So I've got them all in the right order. And then you want to, again, label x1 and y1 and x2 and y2 because we're using them in the formula. So it doesn't matter which one is which as long as you're consistent. So I've labeled those. And now we're going to write down the midpoint formula. So I'm going to write midpoint equals, and our midpoint is an ordered pair. So I have to have parentheses around the whole thing and then a comma in between because our midpoint is an ordered pair. So if you're told to use the midpoint formula, you need to find the midpoint of the whole thing. You can't just do only y. You need to do x and y because otherwise you're not doing an ordered pair. So my x values, it's just averaging them. So 2010 plus 2014 divided by 2. And then I did not leave myself enough room here because these are much bigger numbers. So I'm adding my y values up and dividing them by 2. So I could get lazy and not write midpoint on the left, and I can just put the equal sign there, and it's assumed that that is going to carry down. So that is okay. It's good to show, even though you can do this all in your calculator in one step, it's good to show the intermediate steps just in case you make a calculation error because it makes it easier to find. So I'm going to do my addition on the numerators first before I do the division. And then I will do my division. So I get 2012 and then 4560.5. So we've just found the midpoint by using the midpoint formula. Now the problem says to use the midpoint formula to estimate the sales in 2012. So really what it wants is what is the estimate for sales in 2012. So when we write this as a sentence, we need to make that clear. So you can write we or I, or you can even say the estimated sales, but I usually use we. We estimate the sales in 2012 were, a little better W here, and then I've got my dollar sign, I put my number, and then I need to include the units here, which is million. So we estimate the sales in 2012 were $40,560.5 million. If you want you could, because of the 0.5, you know, you could translate it into something else. You can convert it to trillions if you want and do like 40.5 trillion, but it's best to just leave it with the units that they gave you. And there's no reason that you have to round it to a whole number here, because we use decimals when we talk about trillions all the time, or millions. You'll see, like, even with billion or like 2.5 billion, you know, we allow decimals with those things. So you don't need to round this to a whole number. And as I was speaking with that, I realized that I said 40 trillion when it should have been 40 billion if I was to. But anyway, you could just leave it in the units that you have. Just make sure that you're writing it as a sentence. You're including the year, because that's what we're interested in, the sales for 2012. And then you're giving what the output was with those units and everything. Are there any questions? Well, I will assume that is a no. So this was my last example, because this is basically everything that 1.1 had. It was focusing mostly on midpoint and distance formula. And I think this is, you know, this is enough it's just basically using the formula. And then, of course, giving a lot of information so you know how to show your work and all that kind of stuff. So, that's all I've got. So are there any questions on things that maybe not what I just presented? Because I know the class just started and you may have questions on other things that you might want answered. Okay, not right now, but you will soon. That is fine. And hopefully with my announcements that I send out, any questions you have get answered.
I have one.
Oh, you do? Oh,
yes.
Yes. Ask.
When we're turning in all of our assignments, are we downloading them like a PDF and send them to you through Dropbox?
Mm-hmm. Yeah. So you don't have to type it. Like, it gives it to you as a document or like a PDF or however you want, but you don't have to type it up. And in fact, typing math is usually a struggle for a lot of people. I've gotten good at it because I just do it for you know, all the time. So what you can do is you can print out the actual template, or if you have a tablet like I do, you can just write on the template itself like that. Some people don't even use the template and they'll just do it on a regular sheet of paper, which is fine. And then you can upload it with pictures or a PDF or Word document. But if it's handwritten, I find PDF is best. PDF is best even with Word documents, because I've seen lately Blackboard tries to convert the math into weird symbols if you upload it. So it's probably best to upload a PDF or save it as a PDF. Images work, but those take a lot longer to load. So if you can put those in another form, like a PDF form, that would be good.
Okay.
Yeah, and I have, there are websites to do that. There's a website that I use called jpeg2pdf.com, which I use to just convert pictures into PDF, and you can rotate them so they're all in the same order and everything. And that one's really easy to use. So if you do decide to take pictures with your phone, you can do that. Adobe has a phone app called Adobe Scan that can create PDFs. Unfortunately, you can't upload directly to Blackboard from there, so you'd have to like email it to yourself first. But that's also another good option.
Okay. Thank you.
Yeah, you're welcome. Are there any other questions? My water glass has, you probably can't see it, but it's got the golden ratio on it. Some math water glasses. It was a Christmas gift from my sister a couple years ago, and then the next year she gave me math coasters to go along with it. Well, if there's no other questions, you guys are free to leave, exit. this will all get processed, and I'll email it out tomorrow for you guys. And definitely keep in touch if you have questions, because I am here to help you out. That's what I'm here for. So, so you're welcome to let me know.